Hi everybody, what we're going to be working on today is finding the area of what I like to call simple polygons. Back when you started learning about area, this would have been everything you learned about, but what we're talking about now is things like triangles, trapezoids, parallelograms, and rectangles. Obviously a square is just a kind of rectangle, so we're going to be focusing on the area of those and doing it in a slightly different way, which is using what I like to call a sort of a generic area formula. If you remember from learning this in pre-algebra, you probably learned that there's a different formula for each of these shapes. You're talking about triangles, parallelograms, rectangles, and trapezoids. And I just sort of prefer to focus on one formula that you can memorize for all of them and applying that to a number of different situations, including taking a big, large, irregular shape and breaking it into any of these shapes that you feel comfortable with. Okay, so first of all, to do this, we're going to understand the important parts of these figures. And what those are is basically the bases and the heights. So when I look at any parallelogram, this is a parallelogram. The two different things are the bases, which are examples like that. The bases are the pieces that are usually at the bottom but don't necessarily have to be. And then the height. Okay, the height of any figure is a part that connects the bases at 90-degree angles. That's basically what the height is. So the height connects the bases at a 90-degree angle. So very often what they do on problems like this is they'll give you the information, but they'll also throw like a 5 or something out here. And the reason they do that is to see if you know the important pieces of information. That slant height, or that slant distance, that's not important at all. What we need is only the main height. So we'll go ahead and take a look at a different shape now. Now we're talking about a simple rectangle. Again, my bases are there. If the rectangle is turned on its side, those could also be the bases, which is something unique about a rectangle versus a parallelogram or a triangle. Again, we've got a height of it, which is because we've got 4 90-degree angles. All right, looking at a trapezoid, my bases are the bottom and top. And as you can see, those two are connected by 90-degree angles. So if I were to try to take my other two sides, which again, sometimes they'll give you numbers here, and just to try to confuse you, if I were to try to take those and connect them, I could connect them, but I couldn't at a 90-degree angle. That's not a 90-degree angle. And this is not a 90-degree angle either. If I go ahead and I try to just do one of them at a 90-degree angle, for example, say, okay, I'm going to say this is 90 right there. You can see it won't connect all the way to the other side. The last and most tricky one is the triangle. Because when you start thinking about this, we're always talking about having two bases. And as you notice, you don't really have two bases on triangles. So what we do is we count our bases as being the point on the top and the bottom down below. So in each one, as you can see here, I have my height, and on the other one, again, I have my bases, and I have my height. And these pieces of information have to be given to you, otherwise you can't do the problem. Now, the trick here is remembering that we're going to count that as 0. So when we have a base there, no matter what the number is, we're going to count it as 0. So let's go ahead and look at some specific examples. Now, as you could see before, those are examples that weren't in the notes. We're going to look at specific examples with numbers. The formula we're going to use is one we're going to use all the time, and this is the formula. Base 1 plus base 2 times height divided by 2. So what does that mean? It means you add the bases together, you multiply by the height, and then you divide by 2. You could also divide by 2 and then multiply by the height, but you have to go ahead and add the bases together first. So this formula, if you've seen it before, is the formula for a trapezoid. So basically what we do is we take the most complicated formula, which is the formula for a trapezoid, and if we can memorize that one, we can use it for everything else. All that differs is what are the bases. Sometimes they're the same number, so you get 2 of the same number. Sometimes they're 0 in the case of a triangle. and in other cases it's just a normal trapezoid. But the reality is if we could memorize just this one important formula, we could use it for everything. So we're going to go ahead and start off with this one right here, and this is in your notes. The shape we have is here, and we need to identify what are our bases and what is our height. Well, in this case, our bases are the same because on a parallelogram, the sides are the same, which means this up here is also 10. So now my bases are just simply going to be 10 plus 10 times the height, which is 8, divided by 2. And from there, all you have to do is simplify it. So 10 plus 10 is 20. 20 times 8 is 160. And 160 divided by 2 is 80 units squared. So as you can see, we just follow simple steps once we get our formula and we multiply it. You may have remembered that the area of a parallelogram is base times height, which of course 8 times 10 also gives you 80. Again, the advantage to this is not needing to memorize which formulas are used for which situations and just knowing you need to identify what are my two bases and what is my height. Let's take a look at a second example. Again, same as before, we want to identify what are our two bases and what is our height. Well, you probably can see my height right there is 5. One of my first base is 12, but the question is what's my second base? Well, a rectangle, much like the other one, the bases are the same. So this is also going to be 12. Substituting all those parts in, I get 24 times 5. Now here's one of those examples where you can use a calculator or multiply it out the long way and say, okay, 24 times 5 is 120, I think. But another thing you could do too is you could look at just this piece right here and say 24 divided by 2 is 12, and then 12 times 5 is 60. So you could follow either one of those methods. In this one, I just went ahead and was straightforward with it and said that's 120 divided by 2, which is 60 units squared. You always want to put the units squared on there because we're talking about area. So now we're going to look at a simple trapezoid. Trapezoids can look a lot of different ways. But the reality is the only part that's important to you are what are the two bases and what is the height. So in this case, my bases are very clearly drawn out. I've got 7 and 15 for bases and 6 for the height. Doesn't matter which one you put first, 15 or 7 is fine. Adding it up, you get 22 times 6, which again, you could just look at the 22 divided by 2 and get 11. 11 times 6 is 66, or you can go ahead and multiply it out. 132 divided by 2, sure enough, is 66 units squared. The last example, and the only one that I think is a little bit tricky, not that it's hard to do, but what you need to remember is on a triangle, you obviously have a base of 10. But since that one thing up there has absolutely no distance, it's just a point, how could you name it? Well, what we do is on a triangle, that base is 0. So our second base is always 0 on this one. So very simply, 10 plus 0 times 7. 10 times 7 is 70. And 70 divided by 2 is 35. So as you can see, that's still not hard. It's just tricky because it has ones that you have to remember that the second base is 0. So on that note, we're going to try a couple on our own. Remember the formula is base 1 plus base 2 times height divided by 2. So go ahead and try this trapezoid here, apply the correct formula, and after you're done, go ahead and unpause the video. Alright, so in this case our bases are 6 and 8, and our height is 4. Adding that together, we're going to get 14 times 4. 14 times 4 is 56. 56 divided by 2 is 28 units squared. A very common thing that people do is they'll go ahead and write that 28 units squared inside there. And especially when you break up multiple areas, that way you can kind of keep track of them. So we're going to try out another one here. So go ahead, pause the video. Remember, do use the exact formula, the base 1 plus base 2 times height divided by 2. I understand there are simpler formulas out there, but I want you to get in the habit of using the same formula for everything. If you choose to then go your own direction with it, that's fine, but I want for this lesson and these notes for you to practice that. Alright, so what we're going to go ahead and do is we're going to go ahead and use our bases, which are both 7. The height is 10. And that's going to give you 140 divided by 2, which is 70 units squared. Again, as a habit, go ahead and write that 70 units squared inside here. Alright, so we're going to try another one, this time with a parallelogram. I did put that 9 in there as well. So go ahead and start the problem. Hit pause. Hit play when you think you have your answer. Alright, so hopefully what you realize is that 9 is not important. It is not one of the bases, and it is not a height. So you're going to go ahead and ignore the 9. Our bases are both 4 because it's a parallelogram. They have the same. And our height is 8. 8 times 8 is 64. And 64 divided by 2 is 32 units squared. Alright, the last one you're going to do for practice individually is a triangle. So again, you have 3 pieces of information there. Go ahead and pause the video, give it a try to set up the problem using the formula shown there, and hit play when you're ready. Alright, so hopefully here you ignored the 10 and remember that the base 2 is actually 0 on a triangle. So whatever the other side is, that's 0. 6 plus 0 is obviously 6. 6 times 8 is 48. And 48 divided by 2 is 24 units squared. So hopefully that gave you a good starting point. We're going to do some more practice tomorrow in class. But before we do that, one thing I wanted to do is give you an example of a problem that you'll be doing tomorrow. What that is I'm going to give you pieces of I'm going to give you numbers that are the sides of a very odd-shaped figure. Something that we would never have one formula that we could find the area of. What you have to do then is you have to figure out how could I break up that figure into pieces so that I could calculate the area of the whole thing. And that goes down to basically what we're going to do is we're going to try to break this thing up in some way and then add up all the pieces, because when you break things into pieces, they don't change the area. So what I want you to do is pause the video for a little while and see if you can figure out on your notes how to break up that figure into pieces that would be either rectangles, triangles, parallelograms, or trapezoids. After you do that, go ahead and see if you can calculate the area. I'm going to go over a way I broke it up, that I try to break it up always in the least number of pieces. I'm going to go over how I broke it up, and then from there, if you'd like to, you can go ahead and follow along and check your answer. Alright, so what I did is I went ahead and drew 2 lines. First line I drew was right there, which basically took the top part of the figure and turned it into a trapezoid. Then I drew a second line here, and that turned the rest of the figure into 2 rectangles. I could see tons of different ways to do this, including breaking it up into more pieces. The key is every time you break it up, you're going to have to figure out what the sides are, so it's best if you can make those simple for yourself. Alright, now the next important thing is to understand what the sides are of each figure. First of all, this is 12. The way I got that is because this right here, this portion of it is 4 from down below. That's 4. Okay, and then the rest of it is 8. So obviously 4 plus 8 is 12. Secondly, what I needed to know the height of it. And I figured out that was 4 because this portion right here, whole thing is 10. This I know to be 4. And then obviously this is 2. So in order for them to add up to equal 10, this one here has to be 4. So what I have at this point is I have 3 shapes. 1, 2, and 3. So I'm going to have 3 separate problems. First, I've got the trapezoid that looks like this. Okay, second, I have a rectangle that have sides of 4 and 12. And lastly, I have a rectangle with sides of 2 and 4. So we'll start off with shape number 1. My bases for my trapezoid are 6 and 12, so 6 plus 12, and then my height is 4. So if I calculate that out, that gives me an area of 36 units squared. Second one, I've got my rectangle. The bases are both 12, so 12 plus 12 is 24. 24 times 4, and then divided by 2 is 48. And the last one, both the base and the top base are 4 each, and the height is 2, which gives me 8. Because this is a piecewise function, meaning I've broken this up, the last step is just to add up all the pieces. 36 plus 48 plus 8 is 92 units squared. So tomorrow in class you'll be given lots of odd shapes. And what I would like you guys to do with them when I see you is you're going to go ahead and cut them up into pieces, not literally, but you're going to draw them and draw lines and make sure that you notice they're pieces and find the area of each individual piece. So for now, go ahead and take the survey below and just let me know that you took it and if you have any questions. I'll see you tomorrow.